This conference will now be recorded.
Hey JP, all yours.
Hey Bobby, this is meant for Vijay, right?
Yeah. I figured you'd run the meeting in Kevin's absence, and then yeah, for Vijay to do the
Okay.
demo.
Yeah, then yeah, Vijay, go ahead with the hardware updates.
So I was just updating everyone that the whole system is up and running right now. I just want to run it by everybody to make sure that we have everything that we need. I think we are at a position where everything is working.
Vijay, do you hear us? We can't hear you anymore.
Did we lose him?
Looks like actually. Let me ping him and see. Okay, while Vijay is coming, I'm just texting him if he has any issues. What else you want to cover besides the hardware updates today? Anything on the workshop?
We're on hold on the workshop until we sort of get at least some sense of what we have and what we can do with it, with the POC.
Okay. I think
we haven't picked. I think I don't know whether we took notes, but we had this discussion last time, sort of about what we wanted from the
right.
POC
Or
before
the
we
minimum requirement, right?
Right.
That's good, Bobby. I think that something is working now with what Vijay has one setup. Let's see. I don't know if Vijay is back. Vijay, are you back?
Yeah, we're back, JP. Sorry, we didn't even realize that the network went down. So we're back.
Yeah, no issues, Vijay. Yeah, go ahead with the update.
Yeah, we need capability to present right now. We don't. I think we need permission to start presenting. We have a presentation, a quick presentation to go over what we have.
Okay, please check. JP, I made you an organizer as well.
Oh, thank you. Okay.
So yeah, this is our 8th report. So we have got connectivity from NXP Broadcom. Broadcom NIC to both the NXPs on slot B and slot C. And then we have dropped off, like I said, 10 boards for rework at Siltronics. And we're going to get 30 more connectors from Molex, and they're going to guide us with the assembly to increase the yield. And then we are planning to assemble 10 more new boards with tier circuits, irrespective of what Siltronics is going to come back to us with. And we need some additional funding for the assembly process. This is just a quick update of the interposer. And then this is the new setup where we have a single port Broadcom NIC connected. But actually right now at this point in our setup, the Broadcom NIC is actually acting as a switch. and we have actually put a soft loop back. And so we have given an IP address to the host, the two NXP cards, and we are able to ping the NXP cards. The NXP cards are able to ping each other and the host. And also you can ping from the NXP cards to the outside world. That's what we've got. So basically there's X4 Gen 4 connectivity through the Astrolabs retimer to the Broadcom NIC. And then we have X4 Gen 3 connectivity from the NIC to the slot A and slot B. Actually, surprisingly, the connection from slot B and C, although there is range reversal, we actually see that the link is coming up with X4 Gen 3. This, according to NXP, should not be working, but we do see it work. There is no problem. But we haven't tested the actual data exchange between them because there is no driver or anything available. But if I do an LSPCI, I do see connection both on NXP on slot B and slot C actually. One as RC and the other as EP. So that's something that's new. So that's why we put it in red. We need to probably get more advice from NXP to see what's happening. So that is one. And then we loaded the Broadcom driver on the NXP thanks to Lee from NXP. He actually sent us the image, and then we were able to get that working. So right now we have an IP address configured on the interfaces, and it's seeing the Broadcom board. Then we are able to verify ping, and then we are able to use SSH and connect to the boards. And then we are also able to ping from the NIC, so the NXP boards all the way to the internet. So we are able to access any public IP at this point. Broadcom is actually acting as the switch, and the host is actually acting as a router, which will actually route the packets out to the network. So this is kind of the setup that you're saying. Our solution for the first, demo or the first release. This is exactly how it's going to look like. So we're able to successfully access to the host from the internet, and then from there we are able to have either serial connectivity or network connectivity, SSH connectivity into the two NXP on slot B and slot C. The host will be doing the NATing and the routing function for the NXPs, two NXPs. And the two Samsung SSDs that are connected to slot C of the NXP has been formatted and actually mounted automatically. So right now we have the complete setup. So there is a subnet, private subnet between the host and the two NXPs. And the public IPs could be through Wi-Fi or Ethernet on the host, and we are able to connect all of them together. And
one question, just for completeness: the Broadcom NIC has external ports. Have those also been tested?
No, we haven't really connected. We don't have a switch with QSFP. If we are going to host, or if we have a router that has QSFP connectivity, then we'll be able to test it. We haven't tested the QSFP port connecting to an external, but we have done loopback test. That is working for a dual port card, but not outside. So right now we are actually practically putting a soft loopback on the NIC card and using it as a switch, basically. So it's doing all the routing for all the three devices we have at this point.
Okay.
So Vijay, if you have two setups, can we connect back to back? Will that work?
Yes, that should not be a problem. If we have another setup up and going, then we should be able to connect it. The host we have does have another slot that we can use, but might be limited to Gen 3. But we should be able to connect another complete setup whereby we have two setups with 4 LX2s and 4 hard disks connected to the same system, the host, and then we should be able to communicate. That should not be a problem. I think that will be probably the setup in Supermicro that we are looking at. I'm not sure if you're going to have. I'm not sure if you're going to have. How we're going to set it up there. Before initially we were looking at just 2 boards to be set up there, but if we need more hard disks, so for example, if you're going to run mini IO kind of systems, they need more hard disks. So in that case, we might have to put 2 systems per host, and so we might have to host probably 4 systems to get like 2 bundles of each. So we have to decide on how it's going to be, and then we can actually put it on Supermicro. Are there any other questions? And next one. Yeah, so this picture we can actually see. This is basically slot A as endpoint, and then NXP and slot C as RC root complex. And then the 2 disks are actually mounted. And the red line that you see there is actually where we're surprised that came up, because that is actually the connectivity from slot B to slot C. We know for sure in our baseboard we have actually done lane reversal, but we are seeing the connectivity successfully coming up. And then if you do an LSPCI, you can see both the Samsungs, you can see the Prescale bridge and the Broadcom Ethernet NIC controller. Then we did an IF config, and you can see the IP address configured as 192.168.1.3. This is the private network. From there, we are able to ping 192.168.2, which is the other NXP, and the host, which is 1.1, which is acting as a router. And then from the NXP, we are able to ping facebook.com, which gets routed through the host to the outside network. All of them are working. And this is in slot A. This is that's slot C, and then this is slot B, where you have endpoint connectivity, which is again the connection within B and the slot. And then we have a root complex connectivity, which is to the Broadcom NIC. And then same IF config, and then you can see the address to be 2, which is on the same subnet. We are able to ping the host and the other NXP, and then go to facebook.com and have full connectivity. So we are able to SSH have full connectivity from the internal subnet to the outside world on both the slots. So if you want to use one of the NXPs, connecting to the hard disk to do the processing, and then you need additional horsepower, we can actually send some more workload to the NXP on slot B, and then return the results back to the host. So we have totally 32 cores now that we could actually work on. So that was the idea that we actually tried with two NXPs on slot B and slot C. So that kind of concludes our presentation. We'll go for a live demo. We just need like 5 minutes to bring everything up. But if there are any questions, we can actually answer it.
What's the test status of the LX2's Ethernet?
Oh, they both are up. You could see if you see I can go back to the slide quickly.
Not the PCIe, not the Broadcom Ethernet, the on-chip Ethernet.
The IF config, if you see the NXP CUC is the login IF config on the NXP actually.
That's the Broadcom NIC, isn't it?
Yeah, the Broadcom NIC with the driver.
I'm asking about the Ethernet controller built into the NXP.
Built in, no, there is no access to the Ethernet controller built in. I think JP, do we have access to the Ethernet controller that is built in the NXP?
Yeah, no. What Peter is referring to the QSFP ports. The
QSFP ports. Okay, no, we haven't really tested it fully. We need drivers for the QSFP ports to test the QSFP. We haven't tested that particular area. We've been focused only on this to get this going, but we can test it out and then get back.
Yeah, I thought somebody had already been working with the team in China on that.
Yeah, they've been testing, but they had some issues. They did let us know.
Oh.
Sorry.
Yeah, I see. So the guys in China, the NXP staff in China have been testing that. I see.
Yes, yeah.
And they haven't declared it working yet.
No, they haven't. We haven't really synced up on that area since we actually had issues with this. We wanted to get this up and running for our demo, and then we'll go back to that and then see what their things are at. The last we had was we needed drivers for the NXP to come up, and then at that point,
Right.
we got issues with this, and then we
Yeah,
started.
I mean, the Ethernet drivers are already there. You probably don't know how to operate them though, which is a fair point.
Yes.
Sometimes, however, retimers and PHYs cause trouble. So that's probably what they're noticing. Those are off the NXP chip. Okay, so anyway, thank you for the answer. So basically, the answer is the on-chip Ethernet isn't working yet. Okay.
No, yeah, you're right. Sorry, I was in the, yeah.
Also, what user land are you using on the LX2? Is it a Yocto built user land or is it Ubuntu derived? In other
I think
words,
it's
pardon?
yeah, Yocto. I think it's actually a
Okay.
bit built. It's a very custom. It's a custom built. It's not a standard Ubuntu. Whatever came from NXP, we just adopted from the document we got, and we adopted that.
Yeah, NXP has two offerings, so I wasn't sure which one you've got. But I guess the key point would be: Have you tried using apt or apt-get to install something? Have you tried using apt or apt-get to install something?
apt-get, no, we haven't tried that actually. I mean, we got this point just now, recently actually. So we're going to try apt-get. I'm not sure if apt-get is available on the.
Yeah, that's the question, right? Because that depends on which user land. Maybe when you bring up your live demo, we can type apt and see if the commands.
Apt and see if we have it. Yeah, definitely.
Yeah, and that will tell us which user land you've got. I can imagine that users would actually appreciate having the Ubuntu derived user land so apt is present so they can install random stuff.
I totally agree with you. So actually,
Okay.
what we can do is if we still have the bit baked one, then we can actually redo it and then get it up. And I mean, we can actually load the Ubuntu version and then get it up and running. I think that will make it much more easier because to get drivers or get software, that would be a very easy approach.
It's nice for getting user land software. Yeah,
Definitely.
You'd still be using an NXP kernel though. So.
Right.
Yeah, I think originally somebody asked for Yocto. I don't know why, but that's probably why. It's probably Yocto you've got, but we can confirm that when you get your prompt up in the live demo.
Sure.
So I guess on to the demo.
Sure. We're just still working on it.
Okay.
So while you're bringing up Vijay, I have a question for Peter. Peter, what is user land software? Is it installed on top of Ubuntu?
Well, NXP, that's the old name of the group within NXP. NXP has two Linux offerings basically. And one is standard Yocto, where you do a giant bit bake and it runs for an hour and basically compiles whatever you want for user land. And that's good for embedded products. But then we also have a Linux called LSDK, where what we do is combine the NXP kernel with a user land that is basically from Ubuntu, currently 1804, and then our installation script adds a few NXP specific user land items on top of that. But the resulting experience is somewhat similar to just running Ubuntu in that you can, apt update and apt install, like if you like Emacs, for example, you can just type apt install Emacs and it'll go grab it from the Ubuntu repos.
Okay.
Yeah. And that's also nice. I mean, if you're trying to develop software natively on the LX2 rather than cross compiling, BitBake is really oriented towards cross compiling, Yocto is. But the LX2 is a reasonably powerful CPU, and so you could also just compile things natively right on the LX2. And sometimes for that you need some random library, rather than having to BitBake and reproduce the whole thing. If you use LSDK, you can just apt install the necessary library from Ubuntu. The chip inside the LX2 is very standard, so user land software from basically everywhere works.
Sorry, go ahead. sorry to interrupt you. Go ahead, please.
I was done.
Oh, sure. Thanks. So basically, we did apt, and looks like I stand corrected. We do have the standard version. Apt-get is working in it.
Oh, good.
Should,
So that means you probably already, well, at least you have apt. That's probably the key thing.
Yeah, we do have the path. If I put
Yeah.
apt, it is working.
Yeah.
So we have both. I mean, I hope you're able to see both the windows. So we have logged into NXP-C and NXP-B. So we call it NXP on slot B as B and then slot C as C. And from here, we can actually ping Facebook.com. This is from C. So ping goes through, we're able to get response from Facebook. So we're able to reach the external network. And then if you do an ifconfig, you can actually see that the Broadcom NIC is available and is configured as IP address 3. And then you do a DF, and you can find the two disks, disk 1 and disk 2. The two NVMEs are mounted on the NXP-C, so you have complete access to it. We've already formatted it to ext4 and then mounted them. So ready for any software installation that we need to do. And this is NXP-B, so you have an config, and you can see the Ethernet controller again, and then we've configured it as 2. And same, you can actually ping the other.
Have you tried anything other than ping?
Yeah, I mean, no, we have done SSH basically. So
Okay. Is iPerf already installed?
iPerf, I can quickly check. I'm
Just
not
type
sure.
iPerf. Just type iPerf, see if it's there.
Yeah, it is there.
Okay,
Yeah.
so do, in that window, do iPerf -S and hit return. And in the other window, do iPerf -C and the IP address of the other LX.
Okay, so let me SSH into it. Before I actually did, just to show, it's working.
Okay.
This is 168. Let's see, right? 1.2. So this is from the host. So if you see it's the ODSA host, we can actually SSH into it, into B, slot B, and then we can actually run a iPerf -C, and then you give the IP address of the host.
Of the other guy, yeah, of the other NXP.
3, yeah, that's 3.
Yeah, and that should work, and we'll pass a bunch of traffic.
Oh, okay. So does it give some stats too? We haven't probably.
Yeah, it runs for this is just a default TCP run, so it oh, that's interesting. That's a user land bug from Ubuntu. that the fact that it's showing you a negative number.
Interesting.
That has to do with iPerf versions.
Version, okay. So it's kind of right now saying it's transfer about 15.9 gigabits of data.
Correct.
Okay, that's pretty good rate, I would say.
Yeah.
So
sounds good.
Sorry, what was that performance?
Actually we don't know exactly because the iPerf version is not quite right, so it doesn't handle a large number, I think.
I see.
Yeah.
Yeah, I think now that we've established basic connectivity, we should take a look at kind of basic performance testing of each component, just to make sure we know what we have to.
Yeah, that's right. And of course the iPerf, that's a totally naive single thread run, right? Not using anything multi-core. So that number probably isn't very high.
Right. We haven't really done any live, testing. Probably we'll actually get the right version of iPerf and then actually see if we could actually get. One thing I can try is to go to the host and then I run iPerf from there, because that could be. Let me try that.
Yeah, maybe do the client on the host. You probably have a firewall installed on the host.
Yes, there's no firewall actually. We removed the firewall. We only have NATing on the host.
Perfect then.
Yeah, so we removed that specifically. So to avoid any.
Yeah, we don't need to do all this now, but it's I guess it makes the demo more fun to try things in the demo that you've never done before.
Right.
I think okay. Yeah.
this doesn't, IPERF is not there in this.
No, apt install IPERF.
Yeah, I'll get IPERF installed on the host and then probably we'll test it out, I guess. So that is where we are. So we have complete connectivity on both the systems, and then we have hard disconnect connectivity to it. And then right now we are ready at this point to do the demo, or I mean do our demo. But we need probably one additional system that we can hook up to the same system. So we have like probably 4 hard disks at least, and then 2 different setups. So when a query comes into the host and we're going to submit it to the NXP, then we have like 2 sets of hard disks that are available. I think Mini.io, you can actually keep adding as many as you want, but kind of the minimum they are looking at is 4 hard disks with 2 setups. And if we could actually replicate that, that'll be good. Then we could have, submit a query to both the systems and they can actually do their processing and then come back and give the results. So that is something the team can decide and let us know how many systems do they need per setup. And then accordingly, we can actually test it out and then put it in Supermicro.
So Vijay, the menu requires 4 drives or what?
No, Mini.io, you can actually get away with 2 drives, JP. The minimum, I think, is 2 drives. So we should be able to use 1 NXP and 2 drives and then be done with it. But if we need a proper setup, I mean, according to what they say, more the number of drives it works better. And then they at least insist on minimum for testing purposes. 2 drives are fine, but if you're going to use it a little bit more and test performance and stuff, they recommend more drives, at least 4 or more.
Okay. Yeah, if you have another setup, then we can use a network side of the Broadcom NIC.
Yes. So basically, once we bring it to the network, we can probably put that system also onto the same subnet, and then we should be able to access it, and everybody should be able to access everybody. And once it's networked, then sky's the limit. We can do whatever we want.
Yeah, and I think you also need LX2s, right, for that second setup?
Yes, that was my next request. Was going to be, thank you, JP. Yeah, we only have 2 LX2s at this point in our hand. Maybe we might need 2 more minimum for just to test in our system, and for hosting it in Supermicro, we probably might need another 4 dedicated ones. If we don't go with slot B, additional processing support, if you're looking at additional processing support on slot B2, so then we need 8 of them just to host, basically. So 2 systems per host system is what I'm looking at right now. Again, that depends on how the team is going to advise us. So it's 2 systems per host. We're going to have 2 hosts that we're going to put it on public network, and then each containing 4 NXPs and 4 hard disks with 2 baseboards each. So is there any other questions or anything? We'll actually do the performance testing of the hard drives and the network to see how it is working, and we'll come up with the stats for our next meeting on Tuesday. And then we'll also start looking at the QSFP connectivity and see what is happening on that area. We haven't really gone into that. Once we finish all this testing and everything is good, we'll actually move on to that, and we'll probably get some work done on that area and then get back to you with the results. But since it's the first, sorry.
When you do performance testing, there can be things can change based on tuning, right? So I wonder if it makes sense to get advice from the makers of the on test procedure, from Samsung for the SSD and Broadcom for the NIC. They, like, when Broadcom tests performance, they might not be using default parameters for the network stack, for example.
True. Sure, definitely we'll reach out.
And and so it might be good to test the same way they do.
Definitely. So we'll definitely reach out to Broadcom and Samsung and see what advice they have. I think we're using FIO. I think, if I'm not wrong, I don't really off my head. I don't remember, for testing the disk performance. And of course, I think
Yeah,
Broadcom
and
also
so
has
like,
it.
yeah, FIO is of course a Swiss Army knife tool. So yeah, like
Yeah,
Broadcom might even have a specific script or something that they use.
right. So I think they have one
So
for testing the connectivity through loopback. Probably we'll use the same tool and we'll request them for the parameters they're using and then modify to see if we can actually
yeah,
go between the NXP and the host and vice versa and get some numbers out of it.
yeah,
So that I think will be more.
yeah. And maybe Samsung has an FIO switch, an FIO script.
Right.
Because otherwise, because if you test these things just out of the box randomly, it's pretty apples to oranges.
True. I mean, I think for at least for a demo, I don't think we are going to be needing huge, you know, numbers at this point. But I think,
Yeah, but you don't want to look slow for no good reason.
right.
Okay, I think that last week, Young said the basic objective is to SSH into that LX2 slots and able to access the drives. I think that is established for one setup.
So kind of the precondition to go forward with the demo, I guess. This is only one system, but we need more, then we can actually get more.
Yeah, I mean,
Can you get like sorry to interrupt, can you get like a third LX2?
If we need more LX2s, we need to add more baseboard.
One more.
Sorry, come again.
One more LX2 in the setup. I think you got two right now.
Yeah, so basically another LX2 would be adding another baseboard. Baseboard right now, slot C is used for Broadcom and slot A is used for Broadcom, B and C are used for LX2s. If you need one more, then we're going to add additional baseboard. So that's
the reason I'm asking that is like it just makes it easier, like things like erasure coding and other things for replication. You do need a third component, the minimum.
Yeah, there's just three slots on the board altogether, though. So.
What does that mean?
Well, they're on the proof of concept board. There are three sockets that you can plug processors into or devices into. So two of those sockets are LX2 and one of them is a Broadcom now.
I got it. Okay. So how do we get a third one in?
We do have the host. We do for certain functionalities. For example, if you want to, host something like the initial setup idea that we were looking at was, any queries that are coming in and we, will come into the host, and then the host will do the processing, and then it'll actually pass on to the two NXPs that will do further additional processing if required, is what we were looking at. But and then we'll have two setups, which means that you'll have totally 4 NXPs. Two on slot Bs would be your additional horsepower NXPs that will be doing the processing, and the ones on the slot Cs will be connected to your hard disk, and then we'll be able to go further. But at this point, since we only have one interposer that's fully working, we have one setup, but putting another setup, as soon as we get the interposers sorted out, setting up another setup should be straightforward. And then we'll be able to have access to 4 NXP LX2s on that setup. And we can.
Yeah, I mean, the bare minimum is like 3. I mean, like 4 is better. I mean, I was just looking at, actually demonstrating something like in terms of making usability of it. This is amazing what you've done so far. I mean, it's incredible feat. It just gives more flexibility in terms of like comparison and things, like it makes it a usable system for actual offload in a different way.
Understand.
Yeah, definitely, like more than 3 is fine, but I get the bare minimum. The reason I'm asking for NXP attached to disk storage is really NXP is being used for a lot of acceleration here at the lower power envelope, and that brings in a completely different domain. And when you move chiplets and stuff, I think it will it's something like very different, and there should be a reason for that. If not, it becomes just, you know, an offload card.
Right.
Yeah, I don't want to interrupt you. You may go ahead. Talk about it later.
No, sure. No, we can also use the host for processing, but if you want to do all the processing over, like I said, I mean, we just included slot NXP on slot B for that.
This is the way the replication works, right? If someone wants to get into computational SSDs and stuff, the way replication works, you need at least a bare minimum another node.
Oh, I understand. Okay. If that's the case, then yes, we will have another setup with 2 more NXPs, another NXP connected to 2 hard drives, and another processing NXP on slot B. We could actually replicate this exact setup, but you'll still have one host connected to both the setups. Then logically, like you said, we could have 4 NXPs, 2 connected to the 2 NVMEs, and 2.
Now, how are these connected? Are they connected via PCIe or?
Yes, the NVMe is connected through PCIe to slot C, and slot B and C are connected through the PCIe through the Broadcom NIC. Basically, you have Ethernet connectivity to slot B and slot C.
So when you add like slots B and C, how do they interconnect?
Slot B and C interconnect through the Broadcom NIC.
Yeah, when you double it up, like you
when you double it up, it comes to the host. Basically, the host has another, you know, excuse me.
When you create a second system, there'll be a second Broadcom NIC, and so you'll use their QSFP ports to interconnect the 2 Broadcom NICs.
No, that's what we don't want.
That's all you can do.
Okay.
So
because
how are you looking?
It's physically a separate system, right?
So Ravi, what do you like to see for the second setup?
So I was looking at something else different, right? For example, like if you were to have a system with everything coming to the host and offloading it off to NXPs, I mean, you can demonstrate it in terms of replication and stuff. But what would be the end game, right? Does it make a platform where somebody can like get into and actually test performance and scalability at a bare minimum? And I mean, for example, like if you have eBPFs running on channelized from the host down the routes traffic down to the NXPs, then can the NXPs talk to each other bypassing the host?
Actually,
yeah, they can.
They can at this setup actually, because when you have the Broadcom NIC and the host, the one host will be connecting to 2 Broadcom NICs and all the 4 NXPs, and the host will be actually doing the basic routing, but they'll be able to ping each other in, you know, and every NXP will be accessible. The way it is getting routed is going to be transparent to the NXPs. That's the only difference basically. But in this case, you're having the switch with Broadcom NIC connected through PCIe. But when we add one more, it'll be actually the PCIe will be coming all the way to the host, going on the next slot of the PCIe back to this same system. So we're just adding the traffic coming to the host and going back, and that's it. There's not going to be any difference at all. The subnet will still be like 4 and 5. Right now it's 2 and 3. It'll be 4 and 5, and all of them will be able to access each other.
Yeah, that's fine. But for example, like if you're running like something like database on the actual host, and then you want to like offload traffic to 3 or the NXP somewhere else, then the traffic will have to come up to the host and be routed there in the user space. I mean, if you have something else that would bypass it. Where today you have eBPF. So eBPF, what it does is like basically like it allows you to like compile in a bunch of code and like runs in the kernel space that makes east-west traffic completely like transparent.
Yeah.
So the point
It
is,
sounds it sounds like you need to bring up a picture of what connects to what on the baseboard and the different slots.
Yes.
I'm not
Basically,
sure Robbie's familiar with that.
yeah, that is this picture.
That's well, no, that's not this picture. This picture shows what we're doing in a particular configuration, right? But there's other configurations where, for example, the NXP could be a PCI Express endpoint connected to the host, right?
True.
So the baseboard diagram shows the slot connectivity and lets you imagine what you could do depending on what slot you put what card. And it also shows you the limitations, right? Because if there's no connectivity on the baseboard, then it isn't then it's not possible. So I don't know if you have handy the diagram of the baseboard connectivity showing what SerDes and Ethernet lanes run from what slot to what slot into the host, right?
This diagram is sort of shows the basic connectivity on the
It shows an example connectivity. It doesn't show everything.
The only difference in the baseboard is you can show more of this connectivity, but the basic connectivity different slot remains the same.
Yeah, but if you look at the baseboard diagram, you can see what's possible. In particular, also by putting NXPs like into slot A. And I think it's important that everybody understand that, right? Because the configurations we can produce are limited by the baseboard design.
So this is actually I think, Peter, am I right? This is the one that you're talking about? Yeah.
Yes.
Okay. So this is how the baseboard design is. So
So you can see, right? So it's slot A on the left where it says NXP LX2. That's because this picture's assuming an NXP LX2 was plugged into slot A, and then slot B is the center slot, and slot C is the right one. And it's the wires, the lines going between the slots and the host that are particularly interesting, and also the ones that go to the QSFP connectors on the side. So like you can see, if you want an NXP to connect to the host via PCI Express, you can only do that using slot A on the left and a single PCI Express controller on the NXP, where it's actually a by 8 connection, not a by 16. Its diagram is a little confusing. So only one NXP can connect via PCI Express to the host, and it would be in slot A. But then you can also see what's possible with PCI Express to PCI Express connectivity between the slots and also Ethernet connectivity from the slots on this diagram. So notice slot C has those 2x4s on the side, and so the diagram doesn't show it, but those go to the M.2 slots. So only slot C is physically able to connect to the NVMEs in the M.2 slots. So making a somewhat better version of this diagram and clarifying the widths, and showing the M.2 slots and all that would be helpful.
Yeah, so Ravi, can you draw a diagram what you're looking for the demo with the eBPF or whatever you have in mind? So we should be able to do that without involving the host, but we can find a way.
Sure. I mean, I can put something together on, but these come into performance equations and stuff. But you could do the same mock-up with, just being connected across a Broadcom Ethernet chip. But
Correct, yeah. So if you connect to Broadcom net, then you will not involve host at all between the LX2s.
You could do that, but the point is like, what are you going to demonstrate?
Yeah, that's what we would need to understand what you really need and see if that's possible with the infrastructure we have.
Yeah, I mean, just for a start, yeah, we do that.
Okay. Also, Peter, I'm wondering that you have LX2 has got a compression engine, right? Is it? Can it be enabled to see how it works in this setup?
Now that takes some software. There's a user space. There's a fairly complicated user space API to that's available.
And can you do on inline compression when it tries to when it accesses the drives?
No, I mean it's the compression engine is a separate block, integrated on the SoC as a platform device. So the hardware doesn't place it in line. So basically, software has to read it from the NVMe and then use the decompression engine to decompress, and then software has to decide what to do with the decompressed buffer.
Oh, so okay.
So the compression engine is just a platform device independent from the PCI Express controllers and anything else on the LX2.
Okay. So in that case, do you have to set up DMA once the compression or decompression is done to access the drives?
I mean, there's no software for this, but you might be able to do tricky stuff like if you have, well, I don't know, I guess these NVMEs, I don't know whether they have it or not, but if, there's NVMEs that have memory buffers or memory regions that can be used to let the buffers reside on the NVMe itself, and you could conceivably DMA to them, because the compression engine itself is a DMA capable peripheral, and could do optimizations like that, but of course we don't have software for that. And actually, interesting question is what the capabilities of the NVMEs we've got are. Your basic consumer NVMe like I have at my house doesn't have any of these features, but yeah. So anyway, there's more software needed for that kind of stuff, and really what we've got for the compression engine is really just an API and some demo apps that run in Linux user space.
Yeah, that's fine, but I mean, it's all fine. I mean, what's here is here, and what I was looking at is like something that is different in terms of what can be done with just like throwing into a processor that moves down to like a chiplet based architecture, and that's probably the future, right? And how does the software move towards it? Today there are a lot of flexibilities in where you can move the software around. I mean, you could do a lot of things, just like interconnecting one LXP through a Broadcom NIC to another LXP. There's nothing different. But what is there that's different that you can demonstrate? I mean, I do know the costs and other things are there in terms of how chiplets work, but there's something more to it. And it's got to be easy to run existing applications and get this turbo boost from just plugging in a card.
Yeah, for that you have to decide what you're going to do and create software for it. This platform is intended to be an experimental platform with a degree of flexibility that was possible, given the connectivity that you just saw. And so what you're going to do with it is a separate issue, and others can speak to this, but I think that the goal of the workshop was to say, hey, we have this experimental platform. Does anybody want to experiment?
Right.
Yeah, but I think adding in one more LX2 would have a benefit in terms of the platform.
Sure, but there's only three slots you saw, right?
Yeah.
So if you connect a third NXP, then you can't connect the Broadcom. Do you need it? It depends on what you're trying to do.
Agree. Yeah, it's fine.
Excuse me.
You can also connect 2 or more complete setups, each with 3 slots, to the same host.
Yeah, I think
But
this is good enough
the
for,
connectivity to the host depends on what you put in slot A of each.
okay.
Yeah. Sticking with our original vision that Young laid out, right? That we'll have the S3 select implementation. So do we have all the hardware what we need for the S3 select implementation?
Depends on how you're gonna do it, right? So for example, you can like run everything on an LX2 right there, as long as you have data path traffic like routed to it. And the interesting part is that it's like whether you go down the path of like a microservices architecture where everything is a different host, or you make everything transparent by using something like eBPFs, where it just comes in and like reroutes traffic down at the kernel level to an LX2. But then are you going to offload those route tables to like the Broadcom NIC or somewhere that you're going to bypass the host completely on computations that are done on the LX2? And I think this is like a fair enough, like, you know, prototype on like demonstrating things like that. But it'd be nice to have another LX2 just to demonstrate a integrated, isolated system by itself. If not, you'd have to reconnect another external domain, which I think is okay. Yeah, I think this is good enough.
Okay. Yeah, bring up the second setup would take some time.
Remember running something like a Minio and stuff. I mean, you could run it on any host, right?
Right.
It's a standalone thing. There's not much to do with it. I mean, it's just like, you know, you're routing, you're just making a query. The software does the SQL query on the host and returns the result. So
Hey
that's
guys,
like a no.
Ravi, I apologize. I have to drop off, and JP's organizer. But one quick question, Vijay, JP, we have a schedule to do it this demo on Friday at the ODSA meeting. Some version of this.
Okay.
That should be okay, right? Okay.
Sure, Bobby.
Yeah,
So do we?
Vijay, is that okay for you as well?
No, it should not be a problem. And do we go live demo like what I did right now? How do
Oh
you
yeah,
want to?
let's go for broke. Yes.
Okay. Okay.
Yeah, I think this is great. I mean, like from whatever you've done, it's like amazing. I mean, we're able to like ping each other's stuff, so it should be good.
Thanks. I mean, one thing we could do is if we could get QSFP working, then you know, for demonstration purpose, we can actually put NXP on all 3 slots, have NXP on slot A, do a little bit of routing through the QSFP, and host on the net on a switch, and then the NXP on a switch, and then see if we could get it working. That is one way of looking at it, but this is the setup that we were been you know, discussing and wanted to go with.
Yeah, it's good. It's good. It's pretty difficult to get up. I mean, it's not simple. I mean, given all the drivers and interconnects.
Yeah, for the Friday demo, let's stick with what we have working, Jay.
Yes, yes, JP. But I mean, once we get the second setup, everything is actually transparent. Here, when we say the host, it's actually acting as a router. That's it. It's really, you know, doing routing functions at the kernel level. And we
Yes,
do
it is. Yes,
some
it
kind
is.
of.
Yeah, it is. I mean, this gives a standard interconnect between multiple devices. But
Right.
when it comes to an application level, it's like when you're thinking about things of like offload and like how are you going to like scale up like 24 SSDs in one rack from 3 on a PCIe 4 bus, you want to see that performance in some way on offloads. And that's a software level thing that the way it does it in the software at the host side, or it like directly connects. And
Yeah. So Ravi, we are up to about 3 minutes over. Sorry, we'll take up this more discussion next week, Ravi. So I mean, if you can come out with a block diagram, that'd be great, and then we'll discuss more in depth next week. And the remaining time, I want to understand about the workshop plans. Where do we go from here for the workshop? So do we need a full-fledged demo for the workshop, or what do we do?
I think what you have here is great for a workshop.
Okay. So Bobby, do you have any thoughts on the workshop?
I think Bobby's on, JP. He dropped off, I think.
Sam or Peter, do you have any thoughts on the workshop?
I mean, it was originally scheduled for this Friday, right? And you're talking about when we might reschedule. I think it all depends on the demonstrations, like the Samsung demo. It'd be good to have at least some software. Someone had spent some time developing some demos on this platform ahead of time. I mean, it doesn't have to be a full system, but at least something to demonstrate the capabilities.
Okay. Demo on the.
I receive packets. I use the Broadcom switch or the NIC to bypass traffic into the LX2s. I did some processing on the LX2s.
Some kind of application, right? Right now we're running that iPerf and FIOs and the benchmarks. What you're suggesting is some kind of application to show the capabilities.
Yeah. I'm not talking about benchmarks, just kind of capable, being able to do that offload.
Okay, and Peter, meanwhile, if you have any way we can demonstrate an compression using the flow we have, let us know.
We don't. That would not be a short-term thing.
Oh, okay. So it means it's not going to be for that workshop.
Not after workshops anytime soon. There's real work needed to connect that API to an application.
Okay. Okay, then in that case, we'll leave it that. And I mean, let me also touch base with Kevin and Poppy, and then see if the software demo is viable for the workshop. So Ravi, if you have thoughts on the demo for the workshop, maybe if you can detail that next week, that'd be great.
Yeah, I think like implementing something at this point is not feasible for the workshop, but definitely like putting together like some thoughts and processes on the flows would be like something that may intrigue people to like use the platform.
Yeah, exactly.
And, the point is you build this platform, but yeah, the thing is like, what do you do next with it, and how do you like show that actual software infrastructure works on it, and what's the value add to it? And one of the things in value addition is of course like the total cost of ownership, like Young was mentioning, would be like scaling up the number of SSDs. That couldn't be done today. And maybe putting that on board on like a couple of slides and saying, I mean, it's not implementable at this point in time, but I could like put together something that may entice people to start using the platform towards their development and towards the direction, because eventually this is going to be like scaled up much larger than what it is.
Right. Yeah, and see what can be put together. So I mean, without requiring any development. And if you have thoughts, let's do that next week.
All right.
Okay, thank you everyone. As we are running out of time, we'll catch up next week.
Okay, cool.
Thank you all.
Thank you all. JP, when you have time, we'll sync up regarding the Friday meeting, I guess.
Sure, Vijay.
Sure. Thank you, JP. Thank you,
Yeah.
Ravi.
Thank
Yeah.
Goodbye.
Bye.